Okay, so let's talk about class diagram. Okay, so class diagram is used to model a static structure of the system. Okay, so what is a static structure of system? Okay, this means they do not change over time. Okay, so all the structures, the the relationship, the name, the attribute, the interaction, they didn't do like change over time, and like every time they will change, they completely change the structure. Okay, so instead, they will stay with the same structure over and over time. Okay, so for example, okay, in some cases, student has a name to register different courses. Okay, so this sentence means one student they can register different courses using one name. Okay, they have a relation, they have this operations stay the same. Okay, they won't change. Okay, so another example, like accounting department handles salary and the reimbursement. Okay, which means is so most of the time accounting department will handle all the things related to the money, right? They won't change. Like we didn't like dispute like salary or reimbursements to the maintenance group, right? Or faculty department, right? So they only belong to the accounting department. That's the reason we say, okay, static structure of the system. Okay, we use class diagram to present. Okay, so this can be applied to the different phases of software development. Okay, so we use them to design, we use them to maintain, we use them to testing, because class diagram give us very big and detailed structure of the system, can help us to look at them, to maintain the detail of your systems, to help us to test your systems, to help us to program, to implement your systems. Okay, so I give some example like can help you to refine your system into a programming language. Okay, so which means we involve our class diagram into the design phase. Okay, based on the design of the your system, can help you to refine them this system, okay, into a programming language. Okay, so in the sub of class diagram, we have another diagram we called object diagram. Okay, it is helpful to understand, to help you understand and implement the class diagram basically. Okay, for example, what is object diagram? Okay, the object diagram is specific, concrete object in the system. Okay, that is the same idea when we create instant instance of a class diagram or the class, right? So what is that? What is instance class? Okay, so for example, you have a class. I believe most of people understand. Java, like we have a scanner, right? We have scanner, and we create an object, right? We're using new keyword as scanner, right? System in something, right? So in here, we're using new to create object, right? So this is part of object, then assigned to the object reference. Okay, so scan is object reference. It is a name, right? But basically, we're using this part to create object in your computer memory, right? So this is part of work to create a specific object of a class. In here, we create a specific object of scanner. Okay, we're using the scanner to call the specific um, the method in the scanner class. Okay, so in another example, like if we have a people class, we can create instance of a people, right? So for example, in here we can say, okay, people. So we have a class people. Okay, in here, for example, we have a constructor. The first is name, right? J. The second parameter is for the age. Okay, so PPL is object reference to represent this specific object, right? So this is object diagram to help us to identify your object is unique. Okay, it's not just the people, it's about PPL, right? This is specific object. Okay, so let's say the format first. Okay, how you can use class object diagram to identify, okay, a unique object. So first, we have three ways we can create object diagram. Okay, the first one, we're just using the object's name. Okay, so Max Miller. Okay, if you don't want using that way, you can have class Miller with class name, which is a person. Okay, in some case, you don't want to put the object's name, okay, which is object reference, right? You can just put the class name there. Okay, after that, you have second compartment, okay, which is the current attribute. Okay, the current attributes means we assign the specific attribute value to different attribute in that class. In this example, we know, okay, in person class, we got first name, we got last name, we got a DOB, okay, the date of birth. Then we need make this object unique, okay, which means we need to assign the specific identical value to different attributes. Okay, in here we have the Max Miller, right? So first name Max Miller, last name Miller, first name Max, second last name is Miller. Then we gave a specific date of birth, right? This help us to understand and identify the difference of object. Okay, it's that same idea when you create. So for example, in our class, probably we have two David. Okay, but it doesn't mean they are same person, right? We can identify them using, okay, maybe last name, right? If they have same last name, we can identify with the date of birth, right? If still, okay, we can check their, if there's a one more attribute, probably the living address, right? A phone number. All those things help you to identify the different object. Okay, and based on this, we can link different objects as long as the object has a different, probably interaction. Okay, that look at this example. You can pause for 30 seconds to count like how many objects there, what's the relation you can tell. Okay, just pause 30 seconds. Okay, so in this object diagram, okay, we can tell we have three different students. Okay, name as Helen Lewis, Mike Fox, Paul Strafford. Okay, so this three different objects, right? Then Helen registers the two cores, OM and IPROG. Okay, this is very identical cores, right? It's not just they have the different name. You can tell is one is for winter semester, another for the summer semester, and have different credit, right? And for the course here, they also link with different lecture hall. Okay, so in here for the winter IPROG, we know the different the classroom, right? For this one classroom over here, right? And we know the set and set. So basically, we just count how many objects we have. 1, 2, 3, 4, 5, 6, 7, 8, right? Then what's the relation? The relation we can tell is student has course, right? And the course has the different location. Okay, based on that, we know, okay, there's a different link to help us to understand the relationship between different objects diagram. Okay,